Now, see, I gave a lecture last Friday evening, a different one, at the Copernicus Center in Warsaw. And there were hundreds of young people, boys and girls. And at the end of the lecture, when they finished asking me questions, I told them, now I have one question for you. And that is, don't you have anything better to do than coming and listening on Friday evening? Now, I'm not going to pose the same question to you after 2 beers and who knows how many wines. I'm happy that you are here, and I shall try and not keep you too long here. Now, I'm really privileged to be here. I'm very grateful to have been invited, and to also to have an opportunity to show the highlights of our archives. This is the logo of the Albert Einstein Archives, and this is the logo of my university. Now, this is an Einstein year, and we have been traveling also with these documents, and we have already shown these documents in different places at such exhibitions, like in Rome, at the Grossman meeting, when we had an opening of something similar. Who was represented? There was a representative of the Vatican. There was a chief rabbi of Rome. The imam of Rome was busy, and he could not come. So, you see, this is, we travel with Einstein. Now, see, there is a long story that tells Einstein's road, Einstein's intellectual scientific odyssey to the general theory of relativity. Now, in our book with Jürgen Renn, that is advertised in your folders, we refer to this odyssey as a tale of 3 cities. We talk about Prague, Zurich, Berlin. One can, of course, add Bern, because that's what the equivalence principle was conceived. But in our view, the crucial, the breaking point was when he realized the dual role of the metric tensor. And that happened in Prague. So we have these 3 cities. And on one occasion, Gerald Holton from Harvard is one of the pioneers of Einstein's scholarship in the historical philosophical context, addressed the question, if Einstein would have accepted an offer from another city, and not Berlin, would the same thing happen? Could he have done his general theory of relativity, completed the general theory of relativity? And mind you, here, those years, 15, 16, there was a war, a devastating war. But strangely, in Berlin, which was the capital of physics in those days, there was a vibrant atmosphere of working zeal in the physics community of London, of Berlin. So, addressing this question, Gerald Holton categorically states that no one else but Einstein and nowhere else but in Berlin that could have happened, and he argues about it. So if we accept that, without it. He added something, albeit with a friend, with head of his friends in Zurich, but that's fine. But if we do not argue with him, then I agree with what Hermann Nicolai in his introductory remarks said this morning, that it's very appropriate to hold such a meeting in Berlin and not anywhere else, marking this end of the Einstein era. So that's it. Now, what are we celebrating? You see, this could be a rhetorical question, and I can talk about anything I want. But since I suggested the title, I have to give an answer. There is an answer in the name of this meeting, celebrating the 100th anniversary of Einstein's equation. Now, I will try to give you more reasons to celebrate. And I'm sure that for later this week, you will hear David Gross about Einstein's enduring legacy. I know, because I know what he's going to talk about. I heard him. You will have additional reasons to celebrate. So there are many reasons for a party. So that's what we're doing. Now, let us begin, of course, we celebrate the achievement. And the achievement is not just November 25th, it is the entire month of November. And the month of November is a unique month. We refer to it as the November drama. Now, in this, as you all know, and we all repeat, that in this month of November, Einstein submitted 4 papers, exactly sharp, 7 days interval between each of them. So the first one is on November 4th on the General Theory of Relativity, the second on the General Theory of Relativity and Addendum. Then we have maybe the most important of the papers, and I will tell you in what way, and the field equations of gravitation. Now, here are first just the keywords, but I will tell you something about, I will tell you what is in every one of these papers, what makes them different, and what makes them important. What happened? No battery. I promised you that I should not keep you long. All right, so now, of these papers, first of all, the 4 papers were submitted. Only one of those papers, the third one, was delivered orally. The other, in writing. Now, they were delivered orally because Einstein wanted to make sure that everybody hears the message in this one. And I shall also talk about this one more than I shall talk about all the others. And you will see that this one plays really the key role in this drama. An additional question may arise: why did he wait? He could have waited and submitted one long paper at the end of the month. It's not that he submitted a paper responding to criticism, to suggestions, to questions. You might think that that's why he makes one. No. He submits a paper, goes home, works hard, submits another one, and so on and so on. So on that question, we can we probably have an answer. He was in a hurry because he was concerned that he will be outrun. And he was concerned that he will be outrun by David Hilbert. And the question is, who gets there first? Now, had Einstein read the article by Jürgen Renn and John Stacher and Leo Corey, he wouldn't have to worry. Because it is true that Einstein submitted his paper a few days before, that Hilbert submitted his paper a few days before Einstein, and it has the correct solution, the correct equation. So there was he came there first, and there was some source of bitterness for a while on this occasion. But these three authors whom I just mentioned looked into the Hilbert archives, and they found the galley proofs. And it shows that in the galley proofs, on December 6, Hilbert made a correction to make it look up, to get the correct equations. The original form was not that. It was more resembled something that Einstein abandoned previously, to say a few words, but Hilbert was very gracious. And in the article, it's a famous article, The Foundations of Physics, the first contribution he gives Einstein, the credit. So let us now discuss each and every one of the 4 November papers. So first, on November 4th, you see, Einstein, I'm not taking you through the whole of the thing. There are 2 things that you can do if you want to know how it happened. The easy one, and the fast one, is to read carefully the text labels in the exhibition. The other one, which will take longer, read our book, of Jürgen and myself, which describes it in great detail. But in 1912, the end of 1912, Einstein was very close to the correct answer. He misinterpreted what he had, he abandoned it, and particularly, he did not see that what he had meets the physical conditions. And physical conditions are energy momentum conservation and the expected behavior in the Newtonian limit. And in order to get that, he had to impose certain conditions, and therefore he abandoned that. And he then came up with a theory. And it's very interesting. They published a paper with Grossman. He worked with Marcel Grossman on that. And the paper there, the title, see, the final title is The Foundations of the General Theory of Relativity. But the title on that intermediate paper with Grossman is A Generalized Theory of Relativity. So the care is here. He was careful, but very, very quickly he convinced himself that this is the final theory. That physics does not allow general covariance. It was not a fully covariant theory, and from then until November 4th, or maybe months too earlier, he made a great effort to convince himself and to convince his peers, everybody, the entire community, that this is the correct final theory. And it is slowly he began to understand that all his arguments in favor of that theory were simply wrong, a misinterpretation. And it will be an interesting point, because when I finish my talk, we shall begin to count and to see how many mistakes he made then and after. And we shall even try to speculate which is the greatest of all. So this is, so it turned out a very simple adjustment was necessary. And that adjustment was just to replace what he called, what he believed to be the components of the gravitational potential, namely derivatives of the elements in the metric tensor, to replace them by the Christoffel symbol. And he refers to that error as a fatal prejudice, and then when he writes to Sommerfeld, after he has the final theory, there is an avalanche of letters that he sends to his friends, And we call it in the exhibition, there are a few of that, we call it sharing the joy, sharing the satisfaction with peers. And he writes to everybody how happy he is. Sommerfeld says, the key to the solution was that I realized that the components of the gravitational potential are Christoffel symbols and not what he told them. So, and then Einstein was fascinated. And on the first page there, he writes that nobody who really grasped it can escape from its charm, because it signifies a real triumph of the general differential calculus as founded, and it's capitalized in his manuscript. You will see it. No, you will not. No, you will not see it because you don't have the handwritten version of that. So you will not see his handwriting like that. Anyway, so this is, this is a triumph of a mathematical approach. And we should say a few words about it later. But still, there was something missing. It was still confined to unimodular transformations. So there was still a small constraint on the coordinates, and in the addendum, he removed that. But he removed that at the price of what he calls a bold, an unnatural, for him even an unacceptable assumption on the nature of matter, namely that everything is electromagnetic. And by the way, later, when Hilbert used something like that in his variation principle paper, Einstein called it childish. So now here you have this, and that's what he did. He proposed a new interpretation of the November theory, and so temporarily, considering this unnatural assumption about nature of matter, he got general covariance. But of course, this is not satisfactory. And now comes the third paper. And the third paper has to do with the perihelion motion of Mercury. Now, the perihelion motion of Mercury plays, although a very small effect, a tiny effect, I'll show you what it is, plays a crucial role in the development and also in the final act. Now, what is this? So you have this anomalous precession, the orbit of Mercury is not constant in space, and astronomers already in the middle of the last century, of the 19th century, found that it moves by 5,600 seconds of an arc, 1.5 degrees per century, and they could account the influence of other planets for 5,557 seconds of that, and 43 remained unexplained. Now this in itself to me is a miracle. They had no computers, I don't know what technology, what precision technology they had to observe, but the fact is that the entire community believed this result, that confident that this is a real result, and the 43, and remember this 43, the 43 remained an enigma. And already in 1907, when Einstein launched his intellectual odyssey, in a letter to a friend, Konrad Habicht, he expressed the hope that the new theory will explain these 43 seconds. Immediately after they published their intermediate, so-called Entwurf theory, which later he had to abandon, Einstein, with his very good friend, usually a sounding board, in this case a collaborator, unique case where they worked together. Usually he was Einstein's sounding board. They wrote what we call a very valuable document in the history of science, the Einstein Besse manuscript, 51 pages, half of them written by Einstein, half of them by Michele Besso. 6 of those pages are displayed in the exhibition. And in that document, they calculate, based on that theory, they calculate the perihelion motion of this. And you see here, you can see here, you see he gets 1,821 seconds, and he writes, unabhängig geprüft, proved independently. Now Einstein must have realized that there is here an error of 100. That is independently checked. There is an error of 100, but Besse found the error. And you will see the exhibition with an exclamation mark, that's where the error is. But still, it is 18. It is not 43. And even that did not deter Einstein from developing this utmost belief and confidence in this theory. But what is more important than anything else, that while working on this theory, on this calculation and working out the approximation, Einstein realized for the first time how the Newtonian limit should be understood and interpreted. And he wrote to his friend Michele Besso. And he is, again, one of his partners with whom he shares the joy. How gratifying it is, he wrote at the end, because finally, we are now back to November 1915. Then he got the correct answer based on the new theory, on the November theory. And he writes to him how gratifying it is that finally he got the Mercury orbit correct. But he realized that even in the Newtonian approximations, the D11, D22, I01, they are functions of space, but they do not appear in the equation of motion. So you have the correct limit. That is what Einstein did not understand in 1912. So once he had that, the Newtonian limit, which was the main obstacle, could be put aside. And he was left only with restrictions imposed by the conservation, energy momentum conservation law. And that, let me just here is in writing exactly what I told you about the Newtonian limit. And that he corrected. Now he could go to the next week's paper, because the Newtonian limit was not a problem anymore. So then he, of course, realized that if you modify the way energy momentum appears on the right-hand side of the equation, namely by adding the trace of the tensor, you automatically conserve energy and momentum, and that is it. And the Newtonian limit, you know already, is not a problem, and the way we do it today, because alternatively it can be done on the left-hand side of the equation by adding the trace of the rigid tensor. That is what is usually the form of that equation, and that is what we have. So this is a triumph, and if we want, this is one thing to say, this is what we celebrate. Now, the next thing is the following. So we have this achievement. So now we can ask, what motivated Einstein to launch this odyssey? Because it was a huge effort. It took 8 years. And he very often, to his friends, to Elsa, complained about how hard he is working. And if he doesn't rest, he will go kaput or something like that. So what motivated him? There was no experimental evidence, no empirical observational motivation. On what knowledge can one base a theory? So we have two answers to that. Again, quoting Einstein. In 1917, in this booklet on the special and general theory of relativity, he said that since the introduction of the special principle of relativity has been justified, every intellect which strives for generalization must feel the temptation to venture the step towards the general principle of relativity. Now, there are many intellects, there were giants of physics. Some of them even tried. All of them gave up or did not succeed. Einstein succeeded. And the emphasis here is on must and on the quest for generalization. And there was another reason. There was an inconsistency between Newton and this, and that is also unacceptable. But the main reason, maybe which reflects Einstein philosophy, is in a quotation from his autobiographical notes. And listen to this. I have learned something else from the theory of gravitation, no collection of empirical facts. No matter how comprehensive, can ever lead to the formulation of such complicated equations. They can only be found through the discovery of logically simple mathematical conditions. So he doesn't need experiments. Experiments would not help him in any way to reach the truth. Now, I think if there is anything, the second reason to celebrate is this worldview of Einstein. And by the way, this is the worldview which, on the other hand, brought on him a very strong criticism by people like Philip Leonard of this, who defined this as Jewish physics, putting theory ahead and above everything else. So this and the quest for generalization is, in my view, another reason to celebrate Einstein, because this is what allowed him to get